I received a private message from the Deepin team. Polite, direct, without too much formality. They were inviting me to try out a new technology they were promoting. It's called Linyaps. Now, I'm not someone who jumps on new things with blind enthusiasm. Quite the opposite. As soon as I read Universal Format for Linux, I felt that typical distrust rising that I feel every time someone tries to solve the problems of the Linux ecosystem with a superstructure. Because yes, Linux is a disaster in terms of fragmentation, compatibility, software distribution, but it's also precisely in this disintegration that its deepest strength lives, that wild freedom that no other operating system can guarantee. Yet, I clicked. I opened GitHub, started reading, exploring the repos, and the further I went, the more I realized that this time I wasn't facing the usual poorly documented project thrown out there with 2 contributions and a vague README. No, there's real, methodical work behind this, and above all, a coherent vision. Linyaps isn't simply a new way to package applications. It's a complete system, an architecture designed to bring order and portability without giving up lightness. The heart of everything is called UAB, Universal App Bundle. It's the format in which applications are packaged. But unlike AppImage, where each file is a small, self-sufficient universe, and unlike Flatpak, which relies on heavy runtimes and desktop integration portals, UAB is lightweight, modular, and above all, seriously isolated. Each application runs inside a sandboxed container, managed by a component called LLBox. This LLBox isn't a daemon like Snap. It doesn't stay in the background, doesn't require root privileges, and relies on Linux kernel technologies like namespaces, cgroup, andccomp. In practice, each application has its own little world, with virtual file system, limited access, network isolation if necessary, and all this without affecting the host system. This is already a nice difference compared to Snap, which forces the presence of an active daemon, consumes resources even when not needed, and often slows down startup times. But that's not all. The second aspect that struck me is the partial runtime. In Linyaps, common libraries between multiple applications are downloaded only once, stored in a shared cache, and reused. This means that if you install 10 applications that use Qt, you won't end up with 10 copies of Qt. And this makes a big difference in terms of disk space and updates, because everything is managed incrementally. That is, if only part of the runtime changes, you don't have to download everything from scratch. Just that piece. And if something goes wrong, you can instantly roll back to the previous version, just like what happens in OS tree-based systems. Linyaps, at a conceptual level, behaves like an atomic application management system, but without needing to revolutionize the entire operating system structure. You don't need to change a init system. You don't have to adopt a centralized app store with opaque rules. You can use Linyaps locally, decentralized, even offline. You can create your own UAB packages, sign them, distribute them as you prefer. And there's also an automatic conversion system. You can transform .deb, .rpm, AppImage, Flatpak, or even Snap packages into UAB. It doesn't always work perfectly, obviously, but as an idea, it's disruptive. A bridge, a translator between fragmented ecosystems. And hardware support is also very interesting. Linyaps works on x86, ARM64, Lungarch architectures, and they're working to officially support RISC-V. This makes it particularly suitable for embedded scenarios, ARM devices, home servers, lightweight systems, where Flatpak often struggles and Snap becomes an unmanageable brick. But let's talk concrete numbers. Because theory is one thing, practice is another. And practice, unfortunately for some, speaks clearly. Snap is heavy. The core alone occupies over 150 megabytes. Each application brings its own libraries, and each runtime gets duplicated. The result, wasted space and slow startups. Flatpak is more elegant but not lightweight. Its runtimes are monolithic, shared but bulky, and update in blocks. AppImage is the opposite. Zero installation, a single file, but without sandbox and with duplicated libraries for each app. Linyaps manages somehow to find a balance. Fast startups, even under 3 seconds, no active daemon, intelligently shared libraries, and a reduced disk footprint thanks to the partial runtime system. It's the first time I've tried a universal format that doesn't pretend to be dominant, but simply functional. And the result shows. And then there's the security issue. Each UAB is verified through SHA-256 hash and optionally can be signed with GPG keys. The sandboxing system is configurable. You can decide exactly which system resources each application can access. File system, network, audio, webcam, printers. It's as granular as AppArmor, but simpler to configure. And if an application tries to access something it shouldn't, LLBox blocks the operation and logs the event. There's also an aspect that few are noticing, but which I think is fundamental: compatibility with Docker containers. A UAB package can be converted into a Docker image with a single command, and vice versa. You can take a Docker image and transform it into UAB. This opens interesting scenarios for those working in hybrid environments, where the same applications need to run both on desktop and server. Now, a question arises spontaneously. Why is no one talking about it? Why isn't such an interesting project with so much potential at the center of the Linux debate in the West? Well, here opens an uncomfortable but inevitable discussion. Linyaps is a Chinese project. It comes from Deepin, is maintained by Union Tech, and is part of a broader ecosystem that includes distributions like OpenEuler, UOS, and OpenKylin, all realities with direct relationships with the Chinese state. And here we have to stop for a moment. Because even if Linyaps is open source, even if the code is public on GitHub, the real question is, can we trust it? Who compiles the official binaries? Do reproducible builds exist? Can we verify that the distributed code corresponds to the source code? And more generally, how willing are we to adopt technologies created in a political and cultural context very different from ours? It's not paranoia. It's a legitimate question, and one that must be asked every time we talk about strategic software. Also because the interest in open source in China is not only technical, it's also geopolitical. It's part of a national strategy to free themselves from dependence on Western software. But if China creates open technologies that work well and makes them available to the world, how should we behave? Ignoring them a priori would be stupid. Accepting them uncritically, equally so. The answer is, as often happens, in the middle. Observe them, study them, test them. Understand if they can integrate transparently into our systems. Understand if we can use them without losing control. And here we return to Linyaps. I'm not saying we should adopt it en masse, but I'm saying it should be taken seriously. Because from a technical point of view, it's superior to many of its competitors, because it solves real problems. And because it represents a vision of the future of software distribution that we cannot ignore. In the end, the dilemma is always the same: simplify or fragment, standardize to facilitate, or let each distribution follow its own path. Perhaps the answer is not to choose between the two, but to create tools that allow coexistence, that offer compatibility without imposing homologation. And if Linyaps can do this, if it can really be a bridge and not a wall, then it's worth exploring. Even just to understand what we can learn from those who, in a distant corner of the world, are trying to solve the same problem we've been facing for 20 years. How to make Linux more accessible, more orderly, without betraying its soul. And perhaps right here lies the most fascinating part of the project.